Welcome to this video. My name is Mark Sithian. The date today is February 8th, 2025. This lecture is going to focus on sunlight, its energy, power, heat, and quantum mass upon the Earth. So we can start with the Earth's ground level surface area in square meters, and that is 5.1 times 10 to the 14th power square meters total spherical surface area. Next, we focus on the sunlight exposure over 12 hours. So half the Earth is illuminated. So that would just be half of the spherical surface area in square meters, 2.55 times 10 to the 14th power square meters. So the next point is the sunlight luminescent power, or the light lumens power per square meter, and that is 340 watts per square meter is what the sun's photoluminescent power is over 1 square meter of surface area. Next, we have sunlight energy propagated upon the Earth. So we're measuring this in either joules or foot-pounds or both. So we have to take the half spherical surface area of the Earth times the luminescent power of the sunlight, 340 watts per square meter, and we then calculate 8.67 times 10 to the 16th power watts, and we know 1 watt is also equal to 1 joule per second. So then we improve on this and take the wattage luminescent power, multiply this times the number of seconds in 12 hours, so 3,600 seconds per hour times 12 hours. And then we calculate a value of 7.49 times 10 to the 21st power joules of sunlight energy rather than power. If it's power, then it's joules per second. So then we can divide this into 1.36 to calculate the equivalent foot-pounds energy sunlight transferred to the Earth's surface over a 12-hour period multiplied by 2. So we have 12 hours and then times 2 12-hour segments, 24 hours. So we have 7.49 times 10 to the 21st power joules, or 5.51 times 10 to the 21st power foot-pounds of sunlight energy transferred to the Earth over 24 hours. So then we calculate the sunlight power, so that would be in watts or joules per second, and it's just synonymous with the original calculation because we only get 12 hours of equivalent half spherical exposure upon the Earth. So we'd have to use the calculation in 4a for 5. And then number 6, we have sunlight heat absorbed by Earth's surface. So we measure that in either BTUs per second or BTUs per hour, or calories per second or calories per hour. So we'll use the BTUs per hour and calories per hour heat absorbed by the Earth's surface. So we're assuming this is a sky clear, no clouds day. So this would be like the maximum exposure. So when we work this out, we calculate the 1056 watts per 1 BTU per second conversion factor. So this translates to 22.8 billion BTUs per hour. And assuming no clouds, sky clear, would be the sunlight heat absorbed by the Earth's surface. And that's with respect to a 12-hour time period, because only half the Earth is illuminated, right? So the next and last calculation is the sunlight quantum mass discharge every 24 hours. So we know that the relationship between energy and matter is E is equal to mc squared. Energy is equal to mass times the speed of light squared. So we can simply solve for the mass component in the equation to calculate the quantum plasma mass in the sunlight that grounds onto the Earth every 24 hours. So that is the 7.49 times 10 to the 21st power joules. We divide that by the speed of light squared, or 3.0 times 10 to the 8th power meters per second is the speed of light. Then we square that quantity, so we calculate 83,222 kilograms of quantum plasma mass is delivered from the sunlight to the Earth every 24 hours. So we'll just organize this up. And we also have the equivalent calories per hour heat that we'll calculate as well here. 252 calories to a BTU, so that calculates to 5.75 trillion calories per hour. And then of course it's 24 hours, but it's segmented over 2 12-hour periods, and the sunlight we lose on one side of the Earth is transferred to the other side of the Earth in equal proportion. So we'll just say 24 hours. So right here, other than the rotational kinetic energy of the Earth, which is indirectly connected to the sunlight's energy, we have an isolated sunlight energy, power, heat, and quantum mass consolidated calculation 1, 2, 3, and 4. So just to recap here, sunlight energy propagated upon Earth every 24 hours is 7.49 times 10 to the 21st power joules, or 5.51 times 10 to the 21st power foot-pounds. Sunlight power absorbed by Earth's surface, no cloud, sky clear, 8.67 times 10 to the 16th power watts. Sunlight heat absorbed by Earth's surface, no cloud, sky clear, 22.8 billion BTUs per hour, or 5.75 trillion calories per hour. And then lastly, the sunlight's quantum mass discharged upon the Earth every 24 hours, and that is 83,222 kilograms quantum plasma mass. Thank you for watching this video, and have a great day.